How far can we see in the universe? Imagine looking up at the night sky and wondering just how far our view stretches into the cosmos. That question has fascinated humans for centuries. Today, we have answers rooted in science and discovery. The farthest we can see is called the observable universe. It's a spherical region centered on Earth that includes all light and signals that have reached us since the universe began. This distance is about 46 billion light-years in every direction, making the entire observable universe roughly 93 billion light-years across. This might seem strange because the universe is only about 13.8 billion years old. The reason for this huge size is that space itself has been expanding since the Big Bang. As the universe expands, distant objects move away from us, and their light gets stretched into longer wavelengths, a process called redshift. The most distant individual galaxies we have detected are around 13 to 13.5 billion light-years away. That means their light has traveled almost the entire age of the universe. These galaxies formed when the universe was less than 4% of its current age, roughly 300 to 400 million years after the Big Bang. Some of these early galaxies might contain the first stars, called population 3 stars, or even supermassive black holes. We find these distant objects using powerful telescopes like the Hubble Space Telescope and the James Webb Space Telescope. Sometimes, gravitational lensing helps us see even farther. This is when massive clusters of matter bend and magnify the light from objects behind them. Beyond galaxies, the oldest light we can observe is called the cosmic microwave background radiation. It was emitted about 380,000 years after the Big Bang, when the universe became transparent to light. Today, this radiation appears as microwaves coming from matter that is now about 46 billion light-years away because of cosmic expansion. The idea of how far we can see is tied to the universe expansion theory, a milestone in science that changed how we understand the cosmos. Because space has been stretching, the light from very distant objects started traveling toward us billions of years ago, but the space between us and those objects has grown. So, even though the light took over 13 billion years to reach us, the current distance to those objects can be over 30 billion light-years. This means our view of the universe is limited not just by the speed of light but also by how space itself moves and grows. Thanks to discoveries like Edwin Hubble's observation of the universe's expansion, the Big Bang theory, and the development of advanced telescopes, we can look back in time and see the universe's earliest structures. These milestones have helped us understand the vast scale and evolution of the cosmos, showing us that the universe is much bigger and older than it appears at first glance.